Okay. So the system, I have put this on recording, so I hope everyone is admitted. Yes, fair enough. So in last session we have learned is like how you able to use Athena to to able to get the data from your different layer of your data lake, and also we have learned why it is important to have a file get transformed. Like we have learned how you able to use cset functions of Athena, which is creatable as select functions, where you're able to convert the CSV file into Parquet, and then we run bunch of query against the Parquet, and thereafter we also learn how the performance, performance has been changed between running the query against the CSV file, and then we run the query against the Parquet file. And thereafter we went ahead and created some partition and learn, okay, how it is, when you run a partition, what is different in the query performance as compared to when you run against normal data set, right? Like CSV. uh, I will be let me and then also we have learned, okay, there are something called work group within the Athena, which let you segregate your workload, and then also there are options for you to uh, you know there are some knobs for you to available. Hey, how are you able to tell your query user like how much query they able to run? Thereafter they will be start getting all kind of they will be start getting errors, right? So we have learned like, okay, if we go into any work group, you able to tell, okay, how much they able to run as in, like, user, how much they able to run as per query. This is helpful, especially when you wanted to ensure there is a cost, when you're looking through a cost control where users should not be uh, running. Let's say if there are a table which has a terabyte of a data, but you do not want user to kind of scan the entire terabyte of data, because it may not make sense to have terabyte data being scanned, because it's a costly, and I don't think, and even in a business context it makes sense to scan the entire terabyte of data just to view the data, right? So that's why you're able to do that. And also, as I shared earlier, it has something called federation. So federation allow you to connect to multiple data sources, and allow you to bring the data. So I have wrote a couple of blogs. Let's say if we have this MySQL, if I'm looking to go and connect to the MySQL, I will be providing the source name. I will be creating the lambda which will be going in and connecting to that MySQL database and bringing the data in. So the architecture is like, okay, you have your external data sources, and then you will be using your using the lambda functions to connect to those database, and then bring the data to Athena, and then able to do a query with the data sitting in Athena. Okay, so there are many blogs which I have written uh, for this one here itself, like, how you able to do a query using Athena to bring a data from Oracle database. I have explained this entire process. This is the federation capability which is being available within the Athena, which you're able to go and are able to do a query through external data sources. So you can able to learn about this blog. So this is for Oracle. I have written for other data sources as well, right? So let me put it here. So if you're interested, hey, I have an external data source, how I'm able to connect using Athena, you're able to do that by using the federation capabilities, right? Uh, Thereafter, one thing which was we have not covered in our last session, which maybe I can cover now, is Athena has started offering something called Athena, like, Spark. So Spark, and there are reason for it. Like, okay, when there are user, or actually sets of user nowadays, even if you talk about business analysts, data analysts, or any any people who explore the data, right, data scientists, etc. Their preferred language is either they use either they use SQL to perform analysis, or they start using and they start using Spark. Both of them are distributed. Like when you talk about when I say like SQL, in this case, I'm talking about Presto slash Trino. So earlier it used to be Presto engine. Now with the Athena 3.0, it's a Trino engine. Okay, it's a fork. You can think of an extension or fork of a of a Presto. So, and here you're able to go and start creating your notebook, start using your, like, for instance, I have created mm, this notebook, right? So in the notebook, what you're doing is like whenever you're starting uh, a session for you, and then you're able to write your own query, or you're able to bring your own notebook itself. So this is, just think of like, hey, this is my Athena, or this is my Spark notebook, and I'm wondering if any of you worked on the Jupyter notebook in current job or in your previous job, or have any experience around um, working on the Jupyter notebook. Anyone? Okay. So Jupyter Notebook let you, like, run your Spark code. It's more kind of an intuitive environment where you're able to share this notebook. So you will be able to do collaborations, and then, like, more like visualists look better. Uh, so this is where, like, Jupyter Notebook is very popular in a data analyst or data scientist world, where to work and develop something. So for instance, what we're doing here is, this is the file, and we are reading this file. So here this is Parquet file. We have set that this is the format look like Parquet, and then we will be reading this file and creating this data frame called taxi data frame. So everything is there as in Spark. If you're ever interested in learning what the Spark is, I can able to give you one session around the Spark. But the idea is, this is a Spark syntax where you will be bringing the data as in data frame. Data frame is nothing but, like, just think of a table, but memory based table, where all the data which is being kind of read here is being stored in a memory. So this way it make it super fast, right? Once that is being done, now you're able to, what you're doing is looking to see the count, how much record you have in there, and then you're looking to show top 20. Like when you say show, it's showing like top 20 a record, or 20 records from your data set, right? So once then, I wanted to see, okay, how the table look like. That's where you will be create the table view. Let's say this is how the record look like, but if you're looking to do it table definition, right, it will be giving you table definition, how the table going to look like, etc. And then once you're done with, let's say now you're looking to write this table as an right, to S3. This is how you will be doing. So Spark has something called PySpark, as well as something called Spark SQL. So PySpark is more on the Python extension, or to write a query, whereas the Spark SQL is primarily more around using the SQL to write your query, right? So here, what it did is, right, it wrote back it write the query in your S3, and then this is being done. Here, what we're doing is, now we will be using Spark SQL. So remember, we have created this data frame here, and now we are creating this data frame to a temporary table. So this is the syntax, like, to create temporary table from the taxi data frame, right? We are calling it taxi, and then this is a taxi data frame, and then we are running a select statement against this uh, taxi data, okay, the table which we have created. So simple SQL statement. Uh, Once done, we will be creating a new SQL database out of, like, here is the new database creating syntax. Once done, we will be using a reuse that new database and create this table out of that new data in new database, right? So this is as simple as that. This query can be, can get that. So again, this is, and later you will be showing, hey, can you show me table, like what all tables are there in that particular database, this show table query. And then you will be running so this is like, this is your table name, right? And then you will be running a SQL command against this new table. So this is there, and then this is matplotlib. This is a library which you can use to just to visualize how the data look like, etc., etc. So what is being shown here in this notebook is how you able to use Athena to create a Spark notebook, and then you able to write a bunch of Spark code against your data sitting in a S3. Make sense? I will be just cleaning this entire notebook here. So this is all. These are the functionality which is being available within Athena, which let you do a query against, which let you do a query using the SQL, which we have learned in last session. Now we have learned how you're able to do a query against data sitting in your S3 using the Spark as well. We have also talked about the work group, and then also talked around the federation. You guys can go and learn more about this two functionality, but I will be not covering here. Uh, let's move to so there was it when we were when we were in our last session, right? I have shown how you're able to create a table using create table or using like S3 bucket, right? We have said like, okay, you can point to your S3 bucket and then start creating table, providing the column name, etc., etc. But is it not feasible if you have tons of files, right? If you have lot of files and you do not know your schema upfront. Let's say you just got the file, and those files are big, so you don't know how the schema look like, because opening those files is really tedious, right? So that's where we can use functionality which is there in AWS Glue. But let me take a step back first. Let me formally introduce AWS Glue, and then I can talk about the use cases. So AWS Glue is an data integration service which is being available in AWS for you to interact with the data from different data sources, right? Whether data is sitting in your S3, whether data is sitting in your on-premises, whether it's data sitting in a databases, whether it's data sitting in NoSQL database, right, etc. AWS Glue let you connect to those data sources and able to perform all kind of a transformation, and then let you ingest the data into other other uh, data sources. Let's say if you're looking to bring the data from your relational data store and then having the data being stored into S3. When I say relational database, is more like your MySQL, Oracle, PostgreSQL, MySQL, MS SQL, etc. Thereafter, you already have a data sitting in S3. You're looking to join those data together, and then looking to write back to S3, or maybe you want to write back to your databases. So just think of in a very very high level. It's an ETL, or extract, transform, and a load service, but it has a lot other functionality than the ETL, the regular ETL uh, uh, services, right? So it has first thing which it has is something called data catalog. Other is like data ingestion and ETL, right? So that's where the use case come into picture. Hey, I have bunch of data sitting in my S3. I don't know how the file format look like, or I have data sitting in S3. I have data sitting in my data warehouse like Redshift, Snowflake. I have data sitting in my relational database like Oracle, um, Oracle, MySQL, MS SQL, etc. And then I have a data sitting in my NoSQL like DynamoDB, etc. How the structure look like of all those data, right? So data catalog is nothing but it allow you to create a centralized data repository. What does it mean is like you have a single place where you're able to see what all the data is being stored across different data sources, right? So you're able to see how the data look like in your MS SQL, how the data look like in your in your NoSQL databases, how the data look like in your you know uh, S3, right? All those things. So here, if you see, have I have created all kind of a databases. This is nothing but a virtual representation of a data set in some different databases. For instance, if I click here in this one, what is telling me is okay. There are a bunch of file which is located in this location. If I just go and click here, it will telling me there are a bunch of file which is being located into this place, and I wanted to create a view against it, or I wanted to see how the data look like in this file, right? So I have used Glue Data Catalog feature, which is being available. I will be talking the crawler how you're able to perform this thing, but the idea is like, okay, you will be using the Glue Data Catalog to crawl this data and extract the metadata out of it. So this way, if you're going into S3, hey, I have this bunch of files. I don't know how this file look like. How should I know what's the schema look like, right? Because these are the Parquet file, and it's very difficult for me to read. And if I don't know if the schema are of all the files are same, etc., right? So that's where the Glue comes very handy. It let you create or crawl all the data set and extract the metadata, and able to you're able to see how the data structure look like. So we have crawled the data, and once we're done with crawling the data, this is how the structure look like. Okay, so this is again for your data sitting in S3. You can do the similar work while using the Athena, right? You will be going and providing each and every column, and then you're able to run a query. Whereas what we're doing here is we have crawled the data, and once we're done with the crawling the data, we just created and this metadata, and then now be able to go to Athena and able to run a query against it, right? So here we have this data set called where yeah, this is the database called Amazon customer data. And okay, we have this database called Amazon customer view data set, right? And then we have this bunch of table name is Parquet here, right? So I went ahead and in here, and I will be able to let me run a query against it. Okay. Once I'm running a query, I'm able to see the data, right? I will be running this query against this uh, this Amazon view data set Parquet, and data set. I'm sorry, I should be having that was selected a different work group. So if you're working on a different work group, you won't able to see the data or run the query, right? So the ask is like you have to have a right work grouping being selected, and why character length. Okay, maybe I have made some changes in the data set. So here, one thing which you're able to do is like you're able to showcase, like you're able to change the data set itself. I know why it's failing, because earlier I was showing a functionality how you're able to track the schema changes, but now it should work fine. Okay, so if you see here, right, I'm able to run a query against it. Uh, this like our error bring to another option is, hey, what is like if there's a change in schema? Earlier it was a character, now it's in string, right? So the good part is Glue Data Catalog let you kind of uh, uh, let you compare the schema as well, or you keep track schema changes. So if you see here, earlier it was a character, and then now it's in string. So I have wrote one more blog about it, like how you able to validate a schema right? So here is the blog which I wrote about the same use case. What if there is a change in the schema? How you able to track the change in the schema in AWS Glue? That blog will be helpful for you as well, right? And then why it is important, like, let's say I have this file which has been coming to S3, and have crawled this file and create and had the data, have that metadata been extracted in in AWS Glue. Tomorrow, let's say someone brought a new file which has a different schema. You're looking to compare the schema and wanted to ensure your downstream application, which is like maybe you're feeding this data to your application, or you're using some kind of an ETL, etc., etc. This will be not impacting, if change in schema will not impacting your downstream application, which is very important in production. If there's a change in schema, it should be notifying you and ensuring that you will be taking educated step to fix those issues. So this is a blog which can be helpful or good read for you to understand why it's important to monitor your schema changes and make it. So this glue data catalog let you kind of monitor the change in schema itself. So once now the question is, okay, this is the data catalog. How I'm able to create this data catalog? So this is not only able to read a single file, also it able to help you to read that very complex file. Let's say if you're looking to write a file, and the file is in XML file format. Let's say this is your XML file format, right? An XML file format is very complex in nature. So if you see here, this is how the file look like. It's very, it's not very easy to even to read here, right? So this is very complex structure which we have in this file you see here. So it let you read those complex structure as well within your XML file, and then later you will convert those XML file into Parquet, and then have it read the data. I'm writing a blog on this one too, so this way it get published here, so you're able to read that as well. So this is there, and then if you're looking to read the data from MySQL, for instance, I have data sitting in MySQL database, and I just created this database, and then I have this schema. This is how the schema look like from my MySQL database. Okay. Uh, any questions so far? I know I have covered a lot. Any questions, guys?
Hey, Navneet,
Mhm.
could you explain more what is the Glue data catalog? Is it just the metadata, or is it all the data itself resides there? What is the significance?
So it's just a metadata. There is no data at all. So it do not hold any data. So if you see here, when I went to this data set here, right? So all the data which is there is sitting in this S3 location, which I have shown you here. And what I did here is just extracting the metadata out of the data which is sitting in my S3. So this is the Parquet data. So location is in S3 here, okay? And this is just a metadata for me. So this is, think of a centralized place where I'm able to see all the metadata which is there in my data lake. So imagine this scenario, right? When you build a data lake, it's just not you looking to have one or two files, right? Your the entire enterprise sending the files and having the file being stored. So you wanted to know where all the data look like, and how all the data look like, where the data being reside, etc., etc. So that's where, like, you wanted to create that the centralized repository on top of your data lake, right? So this is how usually it being done, right? Let me create a diagram. But answer to your question, this is just a metadata. Okay. So here, if you have a S3, right, you have brought bunch of file in your S3, right? This is your S3 bucket. You will be creating a data lake where you have brought the data from different data sources and had the data being stored into your S3, right? So that data sources can be any kind of a data sources. You can have a data sources like can have a data source like databases. You will bring the data from MySQL. Then you will be bringing the data from Oracle. You have bunch of files. I don't know. Yeah, it's like bunch of documents. Everything is being getting stored, and then you have a, let's say, let me call it NoSQL, right? NoSQL database, like DynamoDB, etc. So you will be having bunch of data, and all this data is getting stored into your data lake, right? Now you wanted to see how the metadata look like. So this is where it will be creating the metadata out of your data, right? This is your metadata layer. So this is where you will be using the Glue data catalog, right? So this is like you can call it. This is the symbol look like for your Glue data catalog. And now, in order for you to create the metadata, we have something called crawler, which I will be showcasing. So crawler let you crawl the data from your different data sources, and then have the data sources being created. Like let's say I have the data source here in NoSQL. I have the data sources in MySQL, and I wanted to create this centralized repository for everything right here. So I wanted to have a list of tables, which will be database for S3, and then you wanted to have a database for your MySQL, and you wanted to have a database for NoSQL, right? So you wanted to have one single place where you're able to see everything. So this is how your structure look like. Okay. So and then you will be using the Glue ETL to bring the data from different data sources. So this is the functionality of a glue I was talking earlier, right? So you will be using Glue ETL to bring the data from different data sources, and and I'm bringing the data from MySQL to S3, and then in the same time I'm crawling as well. Here I'm crawling as well. I can crawl this everything as such. So I will be creating this centralized repository where I will be having everything being stored. Now once done, like okay, I will be looking to write back to, maybe I wanna write this data, make some transformation, and I wanna write this data back to MySQL. Okay, or I wanna write this data to more advanced like curated layer, or anything as such. So that is there as well. Like you're able to write into. So these are the source for you, and the source can be anything, right? And then you have your this is source, and then you can have your des- then you can have your destination too. So why the heck this is your um, destination. So it can be, again, it can be another S3 bucket where you will be. Remember when we were working earlier, so we have converted that CSV file into Parquet file, and that Parquet file, we was performance. So similarly, you're able to do that as well, right? Hey, maybe this is data coming from MySQL to as a CSV file, or maybe this document is a CSV file, and I wanted to have this CSV file being converted into Parquet file so it can be more performant, etc. Or I wanted to have this MySQL being stored into S3 as a raw layer, right? So this is maybe the raw bucket, and now I have made a bunch of transformation against my MySQL database, and I'm looking to store into in more curated layer or visualization layer, right? So or production layer. So this can be any new data source, or this can be a database, etc. So you can able to write this in S3 bucket. You're able to write that in think of it can be your data warehouse as well. Okay, so this will be your data warehouse. This will be your MySQL or database. Make sense? Is it this is clear now? Was the use of Glue data catalog?
Yeah.
All the data is residing on their source. And if I'm crawling this one here and I'm creating Glue data catalog, the data will be in NoSQL. If I'm crawling S3 and creating the metadata, the data will be in S3. If I'm crawling any NoSQL and I'm creating this metadata, my data will be in NoSQL. No data being held by Glue data catalog. It just use metadata. It just stored metadata information. That's it. So now let's say I have to create there are let's learn this example itself. I have this file. I have this data set here, and now you saw like how this data set looked like, right? It has a bunch of file. I don't have any idea how the data set look like. How I can go ahead and start creating the Glue data data catalog. So you will be using the crawler. So you will be creating crawler in crawler and say like demo your and you will be giving the crawler name, and you will be asking, hey, you want to provide the data source name? Yes. If you see here, it has a list of data sources. It can able to go to any JDBC. When I say JDBC, like all the databases which support JDBC, it able to do that. It able to read the data from NoSQL, and I said like NoSQL, it's your DynamoDB and MongoDB. It able to allow you to crawl that as well, and then also it able to allow you to crawl the data from your Delta Lake. Again, Delta Lake is in Spark. Sorry, Databricks file format, or Databricks being using the Parquet to store the data, so you're able to perform the transactions against the data lake. But again, just think of the Delta Lake is a different kind of file format. Okay, for you to allow you to perform the transaction. So here we are just using S3, right? And then it allow you to crawl the data from your own data set, or it allow you to crawl the data from another data set. As long as this IAM role, which I'm looking to use, having permission to allow to access this S3 bucket, you're able to crawl it, right? So in this case, we're just using our S3 bucket. So you can let me browse it. So you're able to go and browse all kind of a file format here. In our case, we just going and using this here. And if I go here inside, I able to see there are file format called Parquet. Within the Parquet, we have bunch of files, right? So I will be just going to the subfolder here, Parquet, because I wanted to read all the files within it, right? So I have selected this Parquet, ma'am, and then I will be asking to crawl all the folders. Okay, done. Now I will be going next. Hey, which IAM role? IAM role is you might aware it's just this permission. So now what I'm looking to do is I'm looking to AWS Glue service to interact with Amazon S3, right? So this role has a permission to go and interact with other service. So this is what the role is all about, right? It has a bunch of permission to interact with each other. Uh, Thereafter, we will be going and looking to say, hey, where I wanted to have my data being stored, right? Let me add a new database. I will be calling as mm, mm, demo, let's say session. I, I just created this here. I can say this is here. And I have created this database, right? So I will be going and refreshing the demo section file, okay? And I will be saying, like, let's say I will be bringing this Pocket file, S3 Pocket, let's be saying S3. Why I'm giving it just to give a prefix. So let's say if all the data is in S3, it will be just giving me a better idea. Hey, this is the S3 Pocket file, etc., etc. Just to give a better idea, right? And now you have an option to like whether you're looking to crawl this data on demand, you wanted to have like customized like hey, every run it every hour or maybe this during this period of the hour you're able to create this con schedule, but for us we will be just running on demand. So I'm just selecting the on demand. Once done, you just done with creating the crawler, right? So this is how your crawler look like, where it will be going and crawling the data from this location. Okay. So if I go back to and then I will be storing the data in this. I will be storing the metadata in this demo session 5. So remember we have created this data called demo session 5. If I go and look into demos, I don't have any table because I have not performed any crawling yet. So I will go ahead and run the crawler. So what the crawler will be doing is it's going to this S3 location and extracting the metadata out of it. So if I go back into this S3 location, I see here I have bunch of file, but this file is it has a partition as well. Remember we have learned about partition. So partition, it means like all the product category. So this file has something called product category, and it's saying all the apparel being stored under this in this folder. And same here, if you go into Amazon, right, it has a different kind of product categories, whether it's automotive, apparel, baby formula, or baby products or beauty products, etc. So this is the product category. So all the baby's product information is being stored into this. So whenever I will do a query, hey, give me whatever from baby, right? So this way you're able to get that value out of the baby only. So this way it will make your query run much faster. Okay, so let's see what's happened to my crawler. Crawl run, still running. So if you see here, it created one table and it has created bunch of partitions. So if you see here, it's calling it this is a table name, and this is like it has added bunch of partitions. So beauty, apparel, digital music, purchase. So it has added up to 43 partition. So I might have a 43 partition in my yeah. So if you see here, I have 43 partitions or 43 objects in here. So this is like, all those partitions. So it end up adding everything. So if I go back in my database again here, I should able to view the table, right? So this is how the partition, now I'm able to see this table. If I go ahead and click on this table, it will be giving me, this is how the definition of this table look like, okay? So let's see if we are able to find some small file and let's say we are going into the baby one. I don't see any small file. Let me find some. Maybe I can able to find something wireless because I don't think much of Octopus is big as well. Other than this is big as well. Okay, all these files are big, so I won't able to showcase how the definition look like using the S3 select. But the idea is like, okay, if I wanted to showcase you how this data look like. So now next task is, hey, I have extracted the metadata. Now I want to see the data definition itself. So I'll just simply go and click on the view data, and it will take me to the Athena, and now I'm start able to explore data, whatever the data which I have just created, I'm start able to run a query against it, and I'm able to see the data look like. Okay, so if you go here at the end, it will be telling me this is my product category. Let me okay. So this is the partition which I have created based on this product category. Okay, so this is my partition. So this way it will make my query run faster as compared to what I have. If I create this table without any partition. Okay. So and any questions on how you're able to crawl the data? Here I have just crawled the data only using S3 bucket. Similarly, you're able to crawl the data using, let's say I have this RDS database, right? So I have the data sitting in this JDBC connection, right? If I say edit, so it will be showcasing this is my connection. If I can show you the connection here. So if I have to go and connect to the MySQL database and able to extract the metadata, maybe I can show you in next session. You're able to do that as well. So here I have this RDS database. RDS is a relational data store for uh, in 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 Amazon, right? So if you see here, this is my RDS connection. I'm connecting to this data source here, and then I will be running the query and able to extract the metadata out of it. Okay. So and then I have been storing this metadata information in here. So any questions? I hope it's clear now how you're able to create the metadata out of the data sitting in S3, and then you're able to use Athena to query it. Any questions? Okay. So if there's no questions, maybe I can give you an assignment. In next session, I will just try to mimic this step. So find some S3 file or create some CSV file. Just think of like creating CSV file because Excel file is not being supported, right? So just create some CSV file and put that CSV file in S3, okay, and create the crawler and then able to query the data using Athena. So this is what the homework is look like. You will be having a file sitting in you will be having file sitting in S3. Okay. Let's say I'm calling it okay, let's say CSV, and then you will be crawling the data using crawler. Okay. And then you will be creating this metadata here. Sorry, this will be you will be creating this centralized data catalog. Okay. You can call it anything. Here you will be having this metadata being stored, right? Once done, you will be using Athena to query it. You will be using Athena to query it, this data here, like how I showed you an example. Once done, uh, the SQL. Thereafter, you will be using Athena, right? Is like able to query the data, and thereafter you will be using Athena CSET, right? And create table as select. So Athena, and then you will be creating a new table. Sorry, you will be creating a new table called, maybe curated You can name it. We can give any name to the table, and this table format should be look like parking. Okay. So this is your homework for next session. So only once you're able to done this homework, uh, and I will review all of you, and then we can get started with the next section. Okay. Okay. Make sense?
Hey, Navneet, so what about these services? Are they free or
No, you
like?
have to wait for it. There are bunch of services which are there are free tiers, but again, right, assume, right, okay, once you for the crawler, if you're crawling, it has a million crawling free or something, so you have to look for it. And same goes with the glue data catalog itself. But if you have a very small files, csv file, just read it, try it. But again, right, if you're not doing it, you will be not learning anything. So I can be provide as many a session, but as long as you're not doing hands on, you will not going to have any experience at all. Okay, and you will be not able to be part of the job market. So try to complete this homework. Answer to your question. Some of those are free. There are some limits, but I have to research like, okay, what are the limits out there, which comes as under the free tier. Okay. Any questions on a homework side? Raghav, any question?
Nothing on my side. No, I think I understand so far.
Okay, perfect. So hopefully I'm able to see this homework get done by next week from all of you. Okay. And next week, once we meet, I will be going. And so we have learned so far, like how you're able to call the data. I will be able to show you the example, how you're able to call the databases itself. But like once we're done with the crawling, then we're going to learn about, building this ETL pipeline to bring the data from one data sources to another. And also we're going to learn something around, in a Glue data catalog, we have something like, let's say when I was showing you this earlier, right? It has something called good data quality, which is this is a recently being announced. So how you able to create the data quality against your data set itself to validate, if it's it has a same number of column, it has the same number of rows from my source, all those nice things. So we will be learning the data quality too. Okay. So next section we're going to learn about this part of the Glue data catalog. Oh, sorry, AWS Glue, as well as we're going to learn about the data quality. Make sense? Okay. So see you guys in next week. Take care. Bye.
Bye.